You already did several of these types of problems in your exploration today and looked at them. So now we're going to do this, summarize this with some formal notes. A radical function is any function that has at least one radical expression containing the independent variable x. The radical equation is any equation in which at least one expression containing the variable x is the radicand. So if x is the radicand, or if x has a power that has a fraction, a rational exponent, then it's also the radicand. These are equivalent. Nth root of x is the same as x to the 1 over n. X to the m over n is the same as the nth root. The denominator of the exponent is the root of x to the nth power. There's another way to express that. As we've discussed before with even and odd roots, if the index n, the root, is even, then x, whatever the radicand is, must be greater than or equal to 0. You cannot take the square root or fourth root or sixth root or any even root of a negative number. If the index n is odd, if the root is odd, then it could be negative, positive, it can be fractions, it can be anything under the radical. And x can be any real number. The steps to solving a radical equation, as you figured out today in the exploration, is to isolate the radical expression. If there's just one, like on the back side here in this case, we're going to try to just get that radical expression by itself by moving the negative 3 by adding 3 to both sides. Then raise each side to the power needed. In this case, we would be undoing the square root, so we would square both sides. And then when we solve for x, check our answers. It's really important to check your answers because by squaring both sides, let me show you, let's say x was actually 3 and we didn't know it. But now somehow we've squared both sides and we've solved everything. We have x squared equals 9. When we solve, we're going to get x equals plus or minus 3. But the answer was never negative 3 to begin with. It was positive 3. So we have to be careful that by squaring or cubing or raising to the fourth or fifth power, we actually introduce additional solutions to our equation that may not have been part of the solutions to the original equation. So we have to make sure that when we're done, we plug our answers back into the original equation to see if they work. So we're going to look at this with the whole idea of raising the power, because sometimes, right, as you saw, sometimes there's radicals on both sides. And so we have to, raise the power to both sides, but we have to deal with the mess of having this whole expression, not just this radical, raised to that power. And sometimes it's actually given an exponential form. So let's take a look, solving radical equations. In this equation, we only have one radical expression. By the way, this radical expression could also be expressed as x minus 2 to the 2/3 because it's being raised to the second power and we're taking the third root. But I'm just going to leave it like this for now. I want to get that radical by itself. So I subtract 8 from both sides. This gives me 4 equals the cubed root of x minus 2 squared. Now, if I want to undo the cubed root first and then undo the square, I can. I could also, let me show you how to do that first. I'm going to undo the cubed root by cubing both sides. 4 to the third power is 64, so I'm cubing this side and cubing this side. Over here, the cubed root and cubed undo each other. So I now have x minus 2 squared. Now I can unsquare it by taking the square root, and I'll have x minus 2 equals plus or minus 8, because when I take the square root, it's plus or minus. Add 2 to both sides, x equals 8 plus 2, or negative 8 plus 2, giving me 10, or negative 6. I will take both of those answers and plug them into the right side of this equation. The left side is just 12. The right side is the cubed root. You might want to do this in exponential function mode, but you could also go to math. Cubed root of the quantity x minus 2 squared, and then outside of the radical plus 8. So we have two answers. We have 10 and we have negative 6. and both of those answers work. Remember, the left side of the equation was 12. I plugged that in for y sub 1. The right side of the equation is the cubed root of x minus 2 quantity squared plus 8. So I put those in, and both answers work. So in this case, there are no extraneous solutions. There are two answers for x. I could have also done this problem as this. If I had changed this to exponential form, I would have had x minus 2. Oh, not the cube, sorry. Would have had 4 equals x minus 2 to the 2/3. To get rid of that exponent, I would have had to raise this to the 3/2 power, because when we have a power on top of a power, exponent on top of an exponent, we multiply. This would be 6/6, which is just x minus 2 to the first. So I could do the same thing. 4 to the 3/2 power would also give me 8. Don't forget, because we're taking the square root, it is plus or minus though, and because we're doing an even root, whenever we do the even root, we have to do the plus or minus. If it was an odd root, you don't have to worry about it. Now we add 2 to both sides, we get the same answers, so we're good. In the next example, we do not have this root by itself, only that expression 2x plus 4 is being raised to the 4/3 power, which means it's really the cubed root of 2x plus 4 to the 4th. So right now, to get rid of that 3, I'm going to divide. 48 divided by 3 is 16. Now, with this, I am going to undo this exponent by raising it to the 3/4. But that means that I'm taking the 4th root, which is an even root. So in doing that, I have to do plus or minus. So I have 16 to the 3/4 power, which is 8, plus or minus 8. That becomes 12 over 12, which is an exponent of 1, so it's just 2x plus 4. I'm going to subtract 4 from both sides, so I have 8 minus 4, or negative 8 minus 4. Then I'm going to divide both of those by 2. So x equals 4/2, or negative 12/2. We think those are our answers, and they very well may be, but we need to plug them back in to check. So into y equals, I'm going to put in the left-hand side of the equation, 3, in parentheses 2x plus 4 to the power of 4/3. And for the right-hand side equation, I put into y sub 2, 48. I go to my table, I plug in 2. Both answers give me 48. I plug in negative 6. Both answers give me 48. So we are okay. Our two answers are good. They do work in this equation. Here's our next example. This is one that has 2 square roots. I want them to be on opposite sides when that's the case. Unfortunately, there is a plus 1 here. So when I go to square this to get rid of this, the radical on this side, I need to square this, which means I'm really doing 1 plus the square root of 2x minus 12 by 1 plus the square root of 2x minus 12. Because there's an addition sign, I can't just square the numbers in here, I have to expand to multiply. The left-hand side is easy, that's just x plus 1. Now when I do this, I now have to distribute, so I have 1 plus 1 times that is just 1 of the square root of 2x minus 12. Then I'm going to distribute the positive square root of 2x minus 12 to the 1 and to itself. And multiplying it by itself, when I have 2 of the same factor under the radical, it escapes the radical. So I just have 2x minus 12. When I combine like terms on this left-hand side, I have 1 plus, there are 2 of these, 2 square roots of 2x minus 12, plus 2x minus 12. I forgot to combine those terms. So this is actually 2x minus 11 plus 2 square roots of 2x minus 12. And that's equal to x plus 1. But wait, there's more. Because we still have a radical here that we need to get rid of. So I'm going to need to get it by itself. To do that, this 2 is attached to it, by the way. So I'm going to add 11 to both sides and subtract 2x from both sides. That's going to give me negative x plus 12 on the left-hand side equals 2 square roots of 2x minus 12 on the right-hand side. So the first time we squared, we got rid of this radical. We had to expand all of this. It was messy. Now we're trying to get this radical undone, so we're going to have to square. You could divide by 2, but then you're going to introduce fractions, so let's not do that. Let's just square this. Because there's no plus or minus sign between the 2 and this radical, this squared will undo itself. 2 squared will give me 4. And that's a minus 12. I need to the error. All right, going back to this step right here, I should never have put a plus here. This is a product right here. So that should be 4 times. That becomes 2x minus 12, and this becomes 4, and I'm supposed to multiply them. So we're going to take it back to there. This is the mistake I warned you about. So we're going to distribute that, which gives us 8x minus 48 on the right-hand side. My left-hand side was x squared minus 24x plus 144. Be careful of that. I usually don't do that. I was rushing and I missed that. I can't believe I put a plus there. So now we're going to subtract 8x from both sides. This gives us x squared minus 32x plus 144 equals negative 48. I'm going to add 48 to 144. Gives me 192. So if you solve and you don't get any solution, that's telling you that you may have made a mistake to go back and check. So 192 is not a perfect square, but let's see if we can find something that's it's divisible by. 16 and 12. It's not going to add 32. We're just going to do quadratic formula. So I've got opposite of 32 squared minus 4 times a times c gives me 256, which is a perfect square at 16. So anyhow, it's 256. I started doing quadratic formula, so let's just finish with it. Got 32, this is over 2a, so that's 16. It's 32 over 2 plus or minus 16 over 2. That's going to be 16 plus or minus 8. 16 plus 8 is 24. 16 minus 8 is 8. We're going to go back to the original equations that we've plugged in. The left side, square root of x plus 1. Right side's 1 plus the square root of 2x minus 12. And I'm going to plug in 24. And I'm going to plug in 8. Notice 8 gives me a balanced equation, so 8 is the solution. 24 is extraneous, because even though it's a solution to the quadratic that I created by squaring both sides, it is not a solution to the original equation. We have 2 more examples on here. And our next example, we're going to look at, it only has 1 square root, which is nice. And so we just want to get that by itself by adding 3 to both sides. 2x plus 3 equals the square root of 28x plus 29. I have people who do this all the time and they square and then they accidentally square. We talked about this also. You saw a big explanation of this in the exploration. So this is actually 2x plus 3 by 2x plus 3. That gives us 4x squared. That'll give me 6 and 6 is 12x plus 9. On this side, I have 28x plus 29. We're going to get our variables. Since we have a quadratic, get our variables to one side by subtracting 28 and subtracting 29. This gives us 4x squared minus 16x minus 20 equals 0. 4 is a factor of that, so I'm going to try factoring. So I've got x squared minus 4x minus 5 also factorable, gives me x minus 5 by x plus 1. So my zeros will be 5 or -1, or both, I'm not sure yet. So I'm going to go back to my original equation, plug in the left-hand side on the ends for y sub 1, and the right-hand side for y sub 2. 28x plus 29, the square root of that, minus 3. When I go to my table, I plug in 5, it works. I plug in -1, and it worked. So both are solutions for this problem.